All right, so now that we kind of discussed the history of animation and kind of just glanced over how it's developed from the early days to where we are right now, I thought it would just be good to discuss how animation in 3D works, or how animation works in any type of non-hand drawing animation software. So when you're, for example, using a software like After Effects or Cinema 4D, you usually place a keyframe between two values that you want to animate, and then between these two keyframes, the computer then interpolates and generates the frame between them. So I have this just example scene in Cinema 4D where I have one keyframe here at frame 0, and then I have one keyframe then at frame 24. So this is like 1 second of animation in this case. And then if I go ahead and play this, you can see here that Cinema 4D helps to generate the frames in between these two keyframes. So every single dot here along this line represents a frame. And that's basically the unique thing about 3D animation or like animation in After Effects, is that we don't have to draw every single frame between our main poses. The software helps us to do that. It doesn't make our job that much easier, because there's still a lot of work to be done in between that, but actually drawing every single frame in between by hand is obviously a lot more time consuming. So I'll just kind of talk to you about how frame rates work. So usually when you're viewing something on a TV or like a film or something, that's usually being played at like 24 frames per second or 25 or even 30 sometimes. And that's just basically the rate of frames that is being played back to you within 1 second. So usually traditional or hand-drawn animation are drawn on twos, which means animating on every 2 frames basically. And most frequently you would work in 24 frames per second, because if you would work, for example, in 30, that would mean more work for every single additional frame that you would have to animate. And if you are animating every 2 frames in a 24 frames per second frame rate, that would mean that you are animating 12 frames per second basically. So you're animating on frame 1, 3, 5, 7, 9, 11, and so on. And the result of animating on twos or animating every second frame kind of results in this very organic and choppy look that you would get from hand-drawn animation. And that's a look that I really, really like to watch. And you kind of get the same thing from stop motion animation. It kind of just makes the movement feel less calculated and less perfect. And it just feels more alive, I think. So that is why we will be animating our sequence in 12 frames per second. And since we are animating in 3D now, and our software will basically interpolate every frame in between our keyframes, it wouldn't make sense for us to animate in 24 frames per second if I want the 12 frames per second look, right? So naturally, we can just set the frame rate setting, which we already did in our project file, to 12 frames per second. So then we will have the choppy and organic look straight out of the software, rather than having to remove every second frame from our timeline. So our process will basically look like the following. So we will first block out each main pose of our animation from beginning to end. And after that, we'll add some in-betweens and certain movements that needs some additional keyframes, basically. For example, like anticipational movements and follow through and so on. And after that, we will smooth out or spline our keyframes between certain movements, meaning that Cinema will start interpolating the frames in between our blocked out poses. And if you're hearing a lot of scary words right now, like stepped, linear, and spline, and so on, I've just prepared this tiny scene where I'm just bouncing a ball, basically. So I've keyframed this bouncing ball, and I've set the keyframes to different interpolation just to kind of show you what this means. So first here on the left, we have the bouncing ball using the stepped keyframe, or basically the type of keyframing that we'll be using when we are blocking. So we're basically just kind of snapping from one pose to another. And then here we have this linear keyframed ball where we're basically just letting Cinema interpolate every single frame in a linear fashion. So we don't really have any acceleration or deacceleration. It's just a linear movement from one keyframe to another, which doesn't really represent how things move in real life. So we won't really be using this keyframe interpolation a lot, but it's just kind of good to know how these things differ. And then lastly, we have this third animated sphere where we have splined all of these keyframes. So I'll just play all of these 3 in one go, just so you can see the difference between these animations. And you can tell that the spline one is the one that is actually looking like a bouncing ball. And just to kind of help you visualize how these keyframes and what stepped and spline means, I thought I'd just open up the timeline, which we'll be working a lot in once we start to tweak our poses and stuff. So just come up to window here. I'll open the timeline F curve, and I'll take this little hamburger icon here and dock it to the left-hand side of our screen like that. So if I select our stepped sphere now, and just I'm just gonna press Control A and then S to focus in on the keyframes. So the reason why it's called stepped is because that is kind of how the curves of this animation looks like. So we snap from this pose to this one, then from the other pose to the next one, and so on. And this is kind of how our animation will look when we block it. We'll basically just place out each pose just so we can focus on the posing and the timing between each pose. And then once you're happy with the overall blocking, then you start smoothing out one body part at a time and one pose at a time, basically. So it's just to kind of help us structure the animation workflow without getting too focused in on, a certain movement, just so we can kind of like do one pass of animation, then another detailed pass, and then another detail pass on top of that, and then spline it, and so on. So it's just a more efficient way of working, especially when you are working with character animation. If I would do a bouncing ball animation, obviously I would move ahead into the splined keyframe immediately, because I wouldn't really need to plan out the movement. In that case, I can just view it in real time. But when we are working with characters, we have a lot of things moving, so it's just best to kind of block things out, I think. And the linear keyframes basically look like the way they are moving, just straight up, straight lines between each keyframe, and that results in this very linear movement. And as I said, for a bouncing ball, this type of spline doesn't really work. But then when we go ahead and hop into the spline sphere, you can almost see that this almost represents the path of a bouncing ball. So these tangents are basically just a way for us to visualize acceleration and deceleration. So a flat handle of a tangent, so this is the handle of my keyframe. This means that the more I extend this, the more easing of the motion will be into the next movement. And the sharper the curve gets to the next keyframe means the faster it will go until it finally reaches that keyframe. So this is just a visual representation of the acceleration and deceleration of our movements, basically. And we will be splining pretty much every single one of our poses in our animation later. So it's kind of important that you get a good grasp of how these things will work. But obviously we'll do things one step at a time, just so you don't get too confused or too stressed out when you see hundreds of keyframes in your timeline. So if we just go ahead and play this, you'll kind of see how this timing works. So I'll just play it from here. And if I were to, for example, shrink this tangent down, our bounce will look very, very different, because now we don't really have this like hang time, because the longer these tangents are, the more hang time you're going to get at this specific point. So if I just have it super short like this or something like this, you can kind of see how that affects the motion of the ball. And if I go ahead and extend this completely like this, so it gets very extreme, you'll see what that does too. You kind of get this very extreme bouncing motion. And I'll go ahead and do this for the second bounce too, just to see how that feels. It's very stylized and fun, I reckon. So yeah, looking at all these keyframes and like doing the tweaks on these tangents makes me want to hop into cinema and start animating. So in the next lesson, we'll finally prepare our scene and just set things up so we have a smoother ride animating. So yeah, I'll see you in that lesson.